Dear students, I welcome you all for the case study discussion on wireless role of electromagnetics in wireless power transfer systems. In this modern world, we use so many electronic devices, and we need to charge all of them. And this wireless power transmission or wireless energy transmission is the technology which allows the electronic devices to charge without the use of physical medium. So, in the absence of physical wires or physical medium, they definitely depends on the electromagnetics. So, in this case study discussion, we will see how this electromagnetics applies in wireless power transmission. This discussion.
Principle of WPT, wireless power transfer. So WPT is primarily based on the Faraday's law of electromagnetic field, which states that the changing in magnetic field induces voltage in the nearby conductor. In WPT, transmitter coil generates the magnetic field when alternating current flows through it. So, which induces the current in the receiver coil, which is placed within the field. So efficiency increases when both the transmitter coil as well as the receiver coil is operated at the same resonant frequency. Resonant coupling allows a power transfer over a moderate distance with reduced loss. So there are two types of WPT: near field transfer and far field transfer. In the near field transfer, power is transmitted through a magnetic field, whereas in far field transfer, power is transmitted through electromagnetic field.
The key components of wireless power transfer. First, we discuss about the transmitter. It converts an electrical energy into electromagnetic field using in coil or antenna. So, in the power electronics, it converts an AC frequency to optimized transmission. And next, the receiver. It captures all the electromagnetic field and converts back into the electrical energy using coil or antenna. And next, the control systems. It ensures the proper alignment, resonance, and efficiency of power transfer. Next is the shielding and safety process. It protects the users and then the uh, sensitive devices from electromagnetic interference and excessive radiations.
So next we can see about the application of wireless power transfer. So first comes is electrical vehicle charging. It enables the convenience of the display free charging of parking lots or while moving in dynamic charging. So example is QI wireless power transfer, and next is the consumer service. It is widely used for charging the smartphones, wearables, and laptops. Its example is Qualcomm Halo technology. And next comes is medical devices. Power implantations using the insulin pumps can be replaced and reduce the surgical equipments. For this, the example is Medtronic's pacemakers wireless power transfer system. And next is the industry automation. Power plant runs sensors which are used in the environments cannot be connected through wires, so it is impractical to use.
So some of its advantages are it allows transmissions of energy through an air gap without using connecting wires. It eliminates the wires and the connectors. Due to this elimination, there will be a less risk in electrical shocks. So compared to the WPT system, wired system has much less mechanical energy.
And let us see about the challenges in WPT and the effective powers. In this, the power laws are obtained from this concept. The power laws is depend upon the transmitters and for the long distance, and it based on the efficiency. The efficiency are relatable with 70 to 90% or less than nearby field. And the distance between the transmitter and the receiving field, it obtained from the process. And the interface or nearby the electronic device or acquired any components and the control systems to obtain many process, and the high applications and implementations are available in this concept, and based on the digital modulation the WPT system are obtained.
So let me just talk about the future developments which are going to be implemented in the wireless power transfer. So first of all, researchers are working on the materials like meta materials and also the high Q resonators, that is the devices which can minimize the power consumption. So this is very useful in the wireless power transmission field. And also they are also working in the development of combining the wireless power transfer in the field of renewable resources like wind panels and then solar panels as well. So when the energies are generated from these panels, so they are planning to transfer all this energy which is generated from these panels and transfer it powerlessly. So it will be very useful for the renewable resources and also it will be very useful for the future generation as well. And also they are planning to develop this using the microwaves and laser, which is considered as the advanced technology nowadays. So with the usage of this, by using this, they are planning to implement to transfer the power and send it to the places which are far away from us, like satellites and drones which are flying in the air. So they are planning to send the power wirelessly through all of this.
Thank you, dear students. You have well explained about the principle of WPT, wireless power transfer systems, and also its types, features, advantages, and applications, future enhancement also. Thank you very much for contributing to this case study discussion on role of electromagnetics in wireless power transfer. Thank you.